All right. So, in today's lesson, we're going to talk about immunity, which we've sort of been talking about for a while, but now we're going to talk about we've been talking about your specific cells in your body, how they fight immunity. We're going to talk about more on a bigger scale how your body as a whole gains immunity, okay? How you build up an immunity. Pause here and have a go at these three quick questions. Have a go at these two more, and we'll have a go at going through these together in class. It's quite an extended response question like you'll have exam likely. All right, so in the study design, we're looking at this immunity topic now, last area of the study design. We want to talk about the different types of immunity and the different strategies for acquiring immunity. And then lastly, we're going to talk about vaccination programs and their role in maintaining what we call immunity for a particular disease in the human population. All right, so vaccines are often in the news. They're often in the news both positively and negatively. For example, all high school seniors opted for a vaccine to combat rising W strain. Our Year 10s just recently got their meningococcal vaccine. Or Australia to stop welfare cash of anti-vaccine parents. Very controversial. Also had, here we go, Donald Trump, gotta love a good Donald Trump quote, talks in talks with vaccine skeptic Robert F. Kennedy to launch vaccination review because vaccines are bad. I was wrong, Pauline Hanson said. She apologised for vaccine allergy remarks. Gosh, even Pauline can say I'm sorry. And then, more importantly, for example, in May 2017, when they were talking about an antibody found in blood of infected people offers hope for Zika vaccine. So there's lots and lots of ways to actually achieve immunity. Vaccine is just one small part of this. This little infographic is going to actually be really handy for you to put into your books and put into your notes. We're going to go through the whole thing together. So the first type of way and the first actual way that you receive any kind of immunity in your life is through what we call natural passive immunity. Okay? It's natural because it's something that's naturally happening to our body. It's not something we're inducing into our body. And it's also passive because it means that your immune system do anything. Okay? And how this happens is during fetal stage, all right, whilst you're growing inside your mother actually gives a specific kind of antibody, immunoglobulin G, that goes directly through your placenta to the your mum's placenta to you as the fetus, okay? Later on in life, once you're born, you actually receive more antibodies from your mum. I often say that feeding your child breast milk is very important. This is all very temporary though, okay? You get these antibodies, but after a while they do get flushed out and no longer work in your body, and you actually have to produce your own later on, okay? The next kind of immunity is very, very similar to passive immunity, right? It's artificial passive immunity this time. So it's just like you receive those antibodies from your mum, we can actually doses of antibodies for a specific pathogen to fight an infection. And a great example of this is in tetanus. And there is a tetanus vaccine, but this isn't the tetanus vaccine. It's simply this tetanus toxoid where we actually directly feed the human the tetanus antibodies so that they can directly fight tetanus straight away. The other kind of immunity that we have is active immunity, and natural active immunity is pretty much what we've been talking about this whole time since we started the immunity topic, all right? And natural active immunity then pretty much just comes together if you get in contact with a specific pathogen, and this causes naive B in those T helper cells and the cytotoxic T cells, and most importantly, we get the production of memory cells, okay? These memory cells are going to go on to be able to create a really fast response down the line, okay? This is natural active immunity. Artificial active immunity works just like, for your body, works just like natural active immunity. But what your body doesn't know is that we're actually going to be introducing into the body the pathogen, right? This specific pathogen, or we're going to be introducing to the body a toxin, right? And when we're saying a toxin, we actually mean an antigen, right? To generate those antibodies, okay? Because of this, your body sort of, when you get a vaccine, in a way, it acts like as if it was being attacked by that pathogen, but without any of the harmful effects of that pathogen. Okay? And most importantly, by getting this vaccine, we're going to get the production of memory cells, which means that if you do get infected with the actual pathogen, you're going to then be able to really easily fight that pathogen now. All right, so let's talk a little bit more about vaccines and vaccination programs. It's very, very common for vaccinations to actually be given in 2 or even 3 injections in relatively short period of time, okay? And this is because the immune response is actually boosted after each exposure to an antigen. All right, let's say, for example, you get a vaccine here at this little graph, okay? It takes a little while for your body to recognize that antigen and have an immune response. And so this is what this graph is showing here. You're getting a little bit of time until we actually are going to get the risk starts here, okay? But once your body gets a response, it quite quickly produces some antigens, but it's going to reach a certain peak, okay? After a little bit of time, your body's body count for this specific pathogen is going to start going down again. So we get what we call a booster shot, okay? This is called the secondary exposure, and the secondary exposure not only is a lot bigger, so we're going to get a massive increase, so more antibodies, but it's also a lot faster. We don't have this latency period that we saw here at the start. We get a quite immediate production of antibodies. All right, and then lastly, the other benefit of vaccination isn't only for an individual, but actually for the population as a whole, okay? So within a population, we actually have individuals which can't actually get immunized, all right? And these individuals can't be immunized are usually the older people, babies, or what we call the immunocompromised, which are people with, because of some kind of health issue, they can't actually, they don't have an immune system that works well enough to have the vaccination programs work for them, okay? So what herd immunity does is if a certain percentage of the population, and usually that number that we talk about is 95%, is vaccinated, it actually can protect this group of people that can't get vaccinated, okay? And so this little infographic shows that, all right? Let's say no one in the population is vaccinated. That means if a certain pathogen shows up, right, in this little infographic, it showed up there in the middle, quickly everyone in the population gets the disease, right? This actually still happens even if something like 50% of the population is vaccinated. Still the disease will pass through the majority of the population. Once we start getting to the bigger numbers, though, as you can see here at 75, it takes a little longer. Even 90%, it takes quite a bit longer. But that 95% number, it means that we can actually stop the specific disease in its tracks, and we'll be protecting this group of people.